This chapter talks about mapping GIS data, which is really the heart of what we're trying to do. There are different ways that we can map data, and those ways are usually dictated by the type of data that we're mapping. To go much further in the GIS field, we want to really understand the differences between types of data. Those data types are nominal, categorical, ordinal, interval, ratio data. Each type of data is best illustrated with a certain type of map. Nominal data can be considered as names or identifiers such as state name, ID number, or owner. Many times this data is simply labeled on maps. Single symbol maps with labels are common for nominal data. The single symbol maps are the most basic. I would rather you think of it as a single symbol feature instead of a single map, because the symbol is really only relating to one data layer of the map. Launch ArcMap and start a new blank map. Browse to your MGIS data folder and expand the USA folder and the USA geodatabase. Add the states, quake history, volcanoes, lakes, and river feature classes by dragging and dropping into your map. By default, layers are displayed as single symbols as they're added into the map. What this means is that all of the rivers use the exact same line symbol. All of the volcanoes use the exact same dot symbol, and all the states are using the exact same symbol. On most maps, things like rivers use the same single symbol. So let's set our rivers layer to use the standard river line. You can double click the symbol from the table of contents, or right click the layer and choose properties, and then select the symbol tab to change the symbols. Just for fun, set the symbol type to unique values. Based on the name, click Add All Values. Now you have a different color line for every river in the data set. Do you understand what unique values means? Set the river symbol back to the standard river symbol. Let's go ahead and set the lakes to the standard lake symbol as well. Categorical data typically groups features into distinct categories such as soil type, geologic rock type, and subregions of the United States. Switch back to ArcMap. Right-click on the States feature class from the table of contents and select Properties from the context menu. And select the Symbology tab. How are the states currently symbolized? Single symbol, right? Change the type to unique values. Remember, when you use these symbol options, you have to tell the software which fields to look into. In this case, pick the subregion field. Pick the Add All Values. This forces the software to examine all the records, and for every unique value, it will assign a different color symbol. How many subregions are there in the U.S.? You could select only certain values by using the Add Values button instead. We can also symbolize the volcanoes based on their type category. Double-click the Volcanoes feature class and select Symbology tab. Set the type to category and unique values. Select the Type field and pick the Add All Values. You can click the count field and see if any features are in the all other categories. If no features are there, uncheck that box to remove it from the table of contents and legend. Back to the PowerPoint for a few minutes. Another data type is ordinal data, which is a ranking category, which is also best mapped using unique value symbols. Interval and ratio data are numeric data along a regular numeric scale. Ratio data has a meaningful 0 point, where interval does not. Quantity symbols are best used for numeric data depending on the type of features. Points, lines, or polygons determines whether graduated color, graduated symbol, or dot density is the best. Graduated colors and graduated symbols use classes to group the values. Classes should be considered as grouping assignments. On this slide, the states with 1 to 92 people per square mile are shown with the lightest pink color. On the adjacent map, states whose population is between 634,000 and 983,000 are shown with the largest star. You can control the color ramps used on graduated color maps. Rainbow colors are difficult to understand, where the natural inference of a single color ramp is that the darker the shade, the higher the value being represented. Often data needs to be normalized or levelized to make valid comparisons. Most normalization is based on an area such as square miles or percentages of the total. Population density means populations per square mile. The word density lets you know that the population is normalized by the area of land. Proportional symbols and dot density maps do not classify or group the features together with proportional symbol types like the symbol sizes. All vary based on their value. Dot density maps do not create an exact number of dots, but represents the density of the dots based on the value. Chart maps are occasionally used. There are different classification methods available. This slide demonstrates the variety of ways the sum data can be presented based on a classification method. Jinx, or natural breaks, is the default classification method used by ArcMap. If you continue to work in a GIS career, your job will be to determine which classification method best fits your data distribution and objectives. Jinx, or natural breaks method, exploits naturally occurring gaps in the data, good for unevenly distributed or skewed data, and is the default method which works well for most data sets. Equal interval allows you to specify the number of classes, and the software divides into equally spaced classes. Works best for uniformly distributed data. Not sure where the map went, but it should be there. It's on my screen. Defined interval allows the user to choose the class size. The data determines the number of classes. Works best for uniformly distributed data. The quantile method assigns the same number of features into each class. It may cause very unevenly spaced class ranges. Results depend on data distribution. You'll be required to assign symbols to points, lines, or polygons. You can choose from a large list of available symbols and then edit the properties to get the desired results. There are a number of prepackaged symbol styles to help standardize your mapping projects. You can create and edit new symbols using the Symbol Property Editor. I encourage you to explore these tools. To review, the data type should match the map type. Nominal data is best shown with single symbol. categorical data is best shown with unique values map. Non-numeric ordinal data is also best shown with unique values map. Numeric ordinal data is best shown with graduated color. Ratio and interval data is best shown using quantity mapping methods such as graduated color, graduated symbol, dot density, or chart maps. To select a single symbol, in the left pane, select Features, Single Symbol, and adjust the symbol by selecting the symbol selector on the right. For unique values, select the unique values under Categories in the left panel, determine the desired field, and select the Add All Values button. For graduated colors, select the graduated colors under the quantities in the left panel, determine the desired field, decide if the value should or should not be normalized, and select your color ramp. If your value should be normalized, select a field to be used. In most cases, you will use an area of land such as square miles or square kilometers. In some cases, you might have to create and calculate this field, but we'll get to that later. We've already discussed that classification methods will influence the appearance of your map. You can specify the classification method by selecting the Classify button on the Symbology tab of your layers. In the Classification dialog box, you can change the method, the number of classes, and also set the class values. You can use the Exclusion button to write an SQL statement that will prevent undesirable result data from being included in your map. Labels are another important part of a good map. ArcMap uses dynamic labels, which means the text value is linked to the particular attribute value. When one is changed, the other changes with it. Labels are a property of a layer and controlled by the Labels tab. They are on or off for the entire layer and are redrawn each time the map refreshes. ArcMap places labels using auto placement to minimize overlaps between labels. The label appearance can be different between what is displayed on a monitor versus what is printed on the map. You want to become comfortable with all the options on the Labels tab. The little checkbox in the upper left corner is often overlooked, but this is how you turn the labels on or off. Labels can be complex strings with fields and even formulas by using the Expression button. You can use special symbols like highway or interstate shields by using the Symbols button. You will want to spend some time exploring all the features of the Label tab. The next few slides demonstrate how to set the label auto placement to better meet your needs. Depending on what type of feature you are labeling, dictates the placement dialog box that you will get. With points, you can specify a ranking of where to place the label in relation to the point. For polygons, you can keep horizontal or keep straight. You can control how duplicates are handled. On align features, you can demonstrate how the label will be oriented and positioned with respect to the line, and you can control how duplicates are handled. The Scale Range button allows you to control at what scales the labels will be shown. This helps reduce map clutter when the entire map is shown. The mapping application on your cell phone does this too. As you zoom in, you get more detailed information about the area that you're looking at. There are two basic types of raster. There's your discrete data, which has a few values and boundaries can be determined, and continuous data, which may have millions of values with no distinct boundaries determined. Rasters can be thematic, representing phenomenon like rainfall or elevation, or they can be image rasters that contain aerial photographs. Image rasters can be displayed with a single band or composite bands. In many cases, rasters are made up of red, green, and blue bands to make natural color composites. To overlay rasters, you may need to set the transparency level found on the Display tab of the Layer Properties. Now let's go back to ArcMap and finish our project. So we'll double check the single feature items, which are the river and lakes. Yours might already be correct, but I'm going to set mine to use the standard symbols for both the river and the lake. Next, I want to use graduated symbols for the volcanoes based on the number of known eruptions. Double-click the volcano layer. Note you can't change the map type by selecting the volcano symbol like we did for the river and lakes before. Select the graduated symbols under the quantities for the left-hand pane and set the field values to known eruptions, size 10 to 30, and use a red triangle for the symbol. We will use graduated symbols for the quake history to layer 2. Set the field value to magnitude, use a size range of 10 to 30, and the symbol should be a light orange circle. Now for the states feature class, we want to show the population per square mile. So double click the states layer from the table of contents. Select the symbology tab in the left hand panel. Select graduated colors beneath the quantities heading. Set the value to POP 2010 and we will normalize the data by square miles so that the normalizing field select SQMI. Now we should set our page up. Pick Print and Page Setup from the File pull-down menu. If you're in our lab, you can select the HP 1050C printer. Set the paper size to Arch D. Check the boxes that say User Printer Paper Settings, Show Printer Margins and Layout, Gap Map Layout, and Scale Map Elements proportionally to change in the page size. This is OK. Then pick OK. If you don't see Arch D size paper, you'll have to go into the properties of the printer and select more sizes and add the architectural sizes to your printer list. Next, we can set some guidelines to help us keep everything aligned. Set your vertical guides at 1, 11.9, 12.1, and 23. Set your horizontal guides at 1, 11.5, 12, and 35. Arrange your data frame in a large area on the right side by selecting the grips and dropping it onto the guidelines. Rename your data frame to be lower 48. Copy and paste your lower 48 data frame. Rename it to Alaska. Resize it to fit in the upper left-hand area of the page. Use the zoom and pan tools to show only Alaska. I like to zoom extents and then use the zoom window. Copy and paste this data frame and position it beneath it. You can rename the data frames. The lower one will be Hawaii and the upper left will be Alaska. It's good practice to use nice round scales for your map. So select the Hawaii data frame and set the scale to 1 to 2.5 million. Insert the scale text using the Insert pull-down menu and place it inside the Hawaii data frame. Select the Alaska data frame, round the scale to 1 to 14 million by typing 14 million into the scale box, and insert the scale text for Alaska as well. We're going to insert a scale text into our lower 48, which has been set to a scale of 1 to 8 million. And we're going to also insert a north arrow. I'm not too particular about which north arrow you like. They just don't need to be too big. They usually come in about the right size. And we're also going to insert the title of the map. We're going to call this map United States, and then underneath that we're going to put population per square mile, earthquakes, and volcanoes. Initially, the title is linked to a property of the map document, but you can remove the link and type in whatever text you like. So in this case, I'm going to put United States and then have a field return that explains, puts on the second line, population per square mile, volcanoes, and earthquakes. I think that should do it. I'm going to lower the text font size to that to probably a 48. Should be pretty good. And I'm going to add my name using the text tool. Next, last thing we want to do is export our map to a PDF file, and then we'll double check our PDF file and then we'll submit our work. If you have any questions, you can give me a call or send me an email. Thanks.